one thing I forgot to mention, remember, I did mention Zwitterion, isn't it? Now, in the in the previous video, I showed that directly, if let's say this was my amino acid, and if I add a base to it, what will happen? So let's say uh, this is my amino acid. I'm just giving the R portion as R, so I'm not writing it. So I just let you show. I just draw this one, isn't it? So I added an hydroxide here. What happened? This carboxylic acid reacted with this one. I said that much, isn't it? So that was the basic concept, like what happens, okay, isn't it? Now, the underlying thing is a better approach is to take it in this way. So let's say we have let's say this is our, which component was this one? This is our alanine. Yeah. So alanine is this one. Okay. So this is our alanine. Ala. This is serine, and this is glycine. Okay. Now alanine has what? Sorry, I forgot to give the H plus here. Yeah. So alanine forms a Zwitterion. Zwitterion does what? It sort of the carboxylic acid loses the H plus and the amine gains the H plus. So that's what is happening. Carboxylic acid lost its H hydrogen towards the amine, and amine gained the H plus, forming a positive charge. So we have what? A negative charge ion and a positive charge ion, isn't it? Now let's say this was acting as what? This was acting as an acid, and this was acting as what? Base. Now remember from our titration chapter and ionic equilibrium, like we learned what? If an acid and a base reacts, what do they form? The acid, when it reacts, the corresponding molecule it forms, the acid, what it forms is a conjugate base. Conjugate base. And the base forms what? A conjugate acid. Now, to explain this, let's give an example. Let's say we have, just give me a second, let me think. Yeah, let's say we have HCl plus, we have, let's say, which one is better idea? Okay, let's take it in this way. We have H2O plus NH3. Okay, so H2O and NH3. Now this H2O acts like water acts as an acid. In this case, it acts as an acid. I know water is neutral, but it has some polarity. It has some partial acidity. So acid in this case acts as an acid, and ammonia acts as a base. Both are weak, very weak. Ammonia is a weak base, and water is very much weak acid. But still, it is acting as a what? Acid, and this is acting as a what? Base. Now, when this acid base reacts, what happens? Acid loses H plus, donates H plus, isn't it? That means ammonia is going to do what? Gain the H plus, forming ammonium ion. And what does water going to do? It is going to form hydroxide ion. Now water donated H plus, forming what? OH minus. Ammonium gained H plus, forming what? Ammonium ion. Ammonia gained H plus to form ammonium ion. Now this base gained H plus to form what here? This is a conjugate acid. Why? Think of this way. This NH4 plus now has surplus of H plus. That means it is now willing to donate donate H plus. This ammonium ion is now willing to donate hydrogen ion. Now the component which wills or which is willing to donate H plus, and that is what? Acid. Now this OH minus is willing to gain H plus because it has a less H, like it has one less H plus. Here we have a like deficiency of H plus. That means it is willing to gain H plus. Now the component which is willing to gain H plus, that acts as a base, isn't it? So this base ammonia reacted to form a conjugate base, sorry, conjugate acid. Conjugate acid. However, this water, it reacted, since this is an acid, it reacted to form what? Conjugate base. Conjugate base. So that's how it works, isn't it? Now, from this conjugate acid, it will lose H plus ion. From this conjugate base, this will gain H plus ion. Like think it in the opposite way. So let's say NH4 plus OH minus. Now take it in this way. This is now conjugate, like this is now acid. This is now base, acid, base, isn't it? Because this is conjugate acid, conjugate acid, conjugate base, conjugate base. Now they are going to do what? react, and acid is going to lose H plus, forming NH3. It lost H plus, and OH minus is going to gain that H plus, forming what? H2O. Gain that H2O. Now what did they form? Now NH4 plus formed what? Conjugate base. OH minus formed conjugate acid. Okay, so now like this is the process how it deals with. Okay, I hope you got it. Now, why I mentioned it here is basically, let me clear this up. I was saying that this a better approach is which one? To think it in that way. So over here, after forming Zwitterions, this is what? This is the carboxylic acid. This is the acid part, and this is the basic part. I mean the base. Now, from that acid and base, what happened? That acid lost H plus, base gain H plus. Okay, this is formed. So now which one is conjugate acid? This is conjugate acid, surplus of H plus. This is what? Conjugate of base. I mean conjugate base. That means deficiency of H plus. That means it has less number of H plus. It needs a H plus. It will gain H plus. Okay. Now what will happen when we add OH minus over here? OH minus is what? Willing to gain H plus. This one remains itself. Like this is the part of Zwitterion. Buffer solution is what? It will prevent changing of pH. pH of 11 means what? We are adding OH minus. So how Zwitterion will react? Zwitterion will now, instead of like with OH minus, it will like lose OH minus H plus. This Zwitterion will provide H plus towards this OH minus. Now who will provide this OH minus? Who will provide this H plus? Carboxylic acid is now conjugate base, and this is conjugate acid. Who is acid? That will react. Now who is acid? This is acid. So this NH3 plus is going to react with this one, forming what? NH2. NH2 will now become neutral. What will we have? We will be having CH3 and COO minus. That means this OO minus remains. Okay. Previously I showed what? That carboxylic acid is donating H plus, but this is actually the underlying thing. This is actually what is happening due to the presence of Zwitterion. Got it? Now, similar things goes for here. OH minus is added. Who is going to lose H plus? Since this is base, NH3 is going to like donate a H plus, forming what? NH2 having H, CH2, OH, and COO minus. Finally, we have what? Here we have glycine. Glycine also doing the same thing. OH minus, when it is added, it forms NH2, CH, and there is an H and COO minus. Remember this OH minus reacts with that H plus forming H2O. Okay, we don't need to show that. That's the minority. That's the side product that you don't need to show. But this is the main thing you are required to show, or you are required to observe, because this is the negative ion charges, and negative ions are attracted towards which terminal? Positive terminal. So G was the positive terminal, the anode. Now, the last thing left here is what? The alanine, serine, and glycine tripeptide. This also do the same thing. The carboxylic acid loses H plus, NH2, or the amine gains H plus. So it gained H plus and that lost H plus. Now when we add OH minus, what happens? It's simply this portion is the portion which donate the hydrogen. So forming NH2. Here we have H, CH3, that's our alanine. Then we have our serine, CH2, OH, COO, CONH, CH, H, COO, O minus. Okay, so that's how it, like the final result is. So based on this, our negative ion is formed. Okay, so that's what I missed out, and this is a better approach. I hope you're understanding this one. If you didn't, rewind the video and try to observe it. Pause the video, then try to understand by yourself. Okay, that's all. Take care.